Shine education.
Greetings, travelers! My name is Mike. Thank you for clicking on this video. This is Earthshine Education. This is our sky update for the month of May 2020. On today's scrumptiously delicious menu of astronomical topics, we've got the moon phases for the whole month, including the final, what is called supermoon or full moon of 2020, the final supermoon. We'll talk about why it's called a supermoon in just a little bit. We're also going to be talking about the visible planets, where to find them in the month of May. The AQUARIID meteor shower. Now, I've actually seen this spelled two ways. Here I spell it with one eye. I've actually also seen it spelled with two eyes. I think later on I just went ahead and spelled it with two eyes because that's what I've seen. Either way, it's the same meteor shower. It's in the constellation Aquarius. We'll show you where to look. We have a little update on the comet known as ATLAS. It's also labeled breaking up isn't hard to do. That doesn't bode well for our comet friend. We'll talk about that in just a little bit. First off, let's talk about the moon. Now, the moon's going to be going through its usual phases, as always. Starting out this month, however, we have a full moon right off the bat in the first week. We're going to have the full moon on May 7th. This is the flower moon. Each moon has a name. This one is called a flower moon, and, well, it's springtime and the flowers begin to bloom in May. Hence the name, the flower moon. Supermoon refers to the full moons that sometimes appear a little bit bigger, a little bit brighter as the moon orbits around the Earth. Sometimes it's a little bit closer, sometimes it's a little bit further away, so it looks a little bit bigger, a little bit smaller. All the subsequent full moons for the rest of this year will not be as bright as this particular full moon. So get a good look at it if you have a clear sky. On May 14th, we'll have a third quarter or last quarter moon. On the 22nd, we'll hit new moon phase, so the moon will be in the sky at the same time as the sun. All that light bouncing off the far side, or what some people like to call the dark side of the moon. All that light's going to be bouncing off that side that we don't see. And then on May 30th, right at the end of the month, we'll go back to a first quarter moon. And so that'll start out the next month in June. Let's take a look at these phases if you don't know what they look like, or if you haven't figured out which one comes first or second. We're going to start out with the new moon phase. This actually goes back in time a little bit to April 23rd. In a new moon phase, you don't see the moon at all. This actually is a little bit after new moon. That's why there's a little bit of a crescent there. All the light bounces off the back side of the moon. We don't see any of it from here on the Earth. So we call it a new moon. As the moon begins to continue its orbit, I should say, around our planet Earth, more and more sunlight begins to get reflected back towards us. You'd see a moon like this, a waxing crescent, in the early evening sky, very, very brightly. Now, it'll be out all day. You'll see it in the sky, but you notice it really, really prevalently along the western horizon right after sunset. About a week later, you get to first quarter, so this is actually April 30th, a couple days back. This is April 30th, first quarter moon, half the side that we can actually see is illuminated, or 1/4 of its way around the orbit of our planet. As you continue on, you go from a waxing crescent to a waxing gibbous. It's not full, it's not a crescent, it's kind of in between. A couple nights later, you get to what is called a full moon. The full moon will rise in the eastern sky at the same time the sun is setting in the west. They are at opposite positions in the sky, or opposition. We'll actually talk about opposition a little bit later in the program. But here you see the entire full moon, the mare, or seas of the moon, the darker areas along the surface. This will be on May 7th, so again, starting out the month with a full moon. After the full moon, the moon will begin to kind of look smaller and smaller in the sky. It's an optical illusion. It's mostly less and less light bouncing off the surface. It goes back into a gibbous phase, except now we call it a waning gibbous. So waxing when it's getting bigger and bigger and bigger every night, waning when it looks like it's getting smaller and smaller and smaller, less and less light. Third quarter or last moon, we now have the bright side on the left side. When the bright side's on the right side, that is waxing. Bright side on the left side, that is waning. This is on the 14th of the month. You start to see this rising later and later in the evening to the point where you're seeing it in the early morning, 2, 3, 4 in the morning, rising up in the eastern sky. A waning crescent, like the moon imaged here, right before the sun rises. You'll see just a crescent sliver in the sky. Returning back to new moon phase, and this again is going to be on May 22nd of this year. Then we'll go back into our waxing phases, and we'll actually end our month of May with the first quarter moon, which means we'll go into June, approaching a full moon right away. We'll talk about that next month. Looking back at our menu, what do we got next? Visible planets. Yeah, we should talk about that, because the planets are out. Which ones? Well, you're about to find out. First and foremost, planets don't twinkle. So twinkle, twinkle, little star. That's a thing you can always remember when you go outside and look up in the sky. Stars will be twinkling. They'll be kind of blinking a little bit. It's called scintillation. It's caused by our atmosphere. Stars generating their light from long, long, long distances away. It filters through our atmosphere, and it twinkles when it gets to your eye. Planets, however, are reflecting sunlight. They're fairly close, relative to the stars, of course, and they don't twinkle. So they're like nice, bright orbs in the sky. Now, astronomers, since antiquity, since the dawn of humankind, have looked at the sky, and they've noticed these things. Every culture around the world has different stories and different names for these objects. We use planetes, or the Greek term, wanderer or vagabond. That's where the word planet comes from. That's what we're going to be talking about, these objects that seem to move in the sky relative to the stars. The stars appear fixed for the most part, for at least our lifetimes. They do slowly move over time, but for our purposes, the stars are all fixed points very, very far away, and these planets, or vagabonds, these wanderers, move through the sky, and you can see that over a period of time, a very short period of time. These planets were called the Sun, the Moon, Mars, Mercury, Jupiter, Venus, and Saturn. Now, we know today, of course, the Sun is not a planet. It is actually a star located in the middle of our solar system. The Moon is a satellite orbiting our planet Earth. And the rest of those objects, Mars, Mercury, Jupiter, Venus, Saturn, those are actually planets, other worlds in our solar system. Now, you're probably wondering why I put them in this very strange order. If you saw last month's sky update, you probably know where I'm going with this. If you didn't, well, here's what we're talking about. Those are actually kind of the references that eventually became the names of the days. So we actually still refer to these vagabonds to this day. Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. These are actually from top to bottom Latin, Spanish, French, and Italian. But you can kind of see where the names eventually evolved or devolved, depending on how you want to look at it, into what we call the names of the days of the week nowadays. Let's move forward a little bit and talk about these worlds really briefly. Mercury is very elusive, very hard to see in the sky because it's so close to the sun. But this month, you will be able to see this little rocky world. I'll show you how it moves around in the sky in just a little bit. And the fact that it's only up for a few evenings in the evening sky or a few hours in the morning sky, and then it's gone, and we just don't see it either in front of or behind the sun. Venus is a little bit different from Mercury. Mercury is a small rocky world that is very close to the sun, extremely hot. Venus is even hotter, but it's kind of like the Earth. It's like our evil twin. It's about the size of our planet, a little bit smaller. Very thick atmosphere, very, very bright, still visible in the evening sky. It is currently called the evening star, even though it is not a star at all. It is, of course, the planet Venus. Mars, the bringer of war, bloody red planet, will be still visible in the morning sky. And over time, it'll continue to be visible in the morning sky, along with the other two planets we're going to talk about. Mars, of course, the rocky planet about half the size of our planet Earth. And actually, we're going to be talking about Mars a lot on this channel because there's another rover being built and prepped to be sent to this wonderful world for study to see if there's actually liquid water still on the surface or under the surface of Mars. There's a lot of evidence of water being on Mars in the past, but not in the present. Or is there? We don't know. Jupiter, the largest planet in our solar system, is a gas giant planet. The other planets we've talked about so far are actually rocky worlds: Mercury, Venus, Earth, and Mars. We call them terrestrial or Earth-like planets. Jupiter, or Jovian planets, Jupiter-like planets, are gas giants. This is the largest planet in our solar system. You can see it in the early morning. I'll show you where in just a second. Saturn, the other gas giant that you can see without a telescope. Uranus and Neptune are also gas giant planets, but you do need a telescope to see them. Not as bright as these others. Saturn, actually, through a telescope, you can see this beautiful icy ring system. It's in the early morning sky, so we'll show you where to look in just a second. Quick definitions before we keep going. The phrase conjunction is when two objects appear in the sky or near each other in the sky. They pass each other in the sky. They're not physically near each other whatsoever. It's just an optical illusion from our point of view, from here on Earth as we observe our nighttime sky. Aphelion and perihelion are kind of opposites of each other. Aphelion is when an object is at its furthest point from another object. Perihelion is when it's at its closest point to an object. Sometimes you use the sun or the Earth, depending on what you're talking about, in reference to that. And then opposition is when two objects are in opposite parts of the sky, opposite sides. And I kind of mentioned that a little bit earlier, where the sun's in one part of the sky and the moon's in the other part of the sky. When they're exactly opposite each other, you get a full moon. That's the easiest way to understand how opposition works. Just looking at one part of the sky and then looking at the other part of the sky. So here's where the planets are going to be throughout the month. Mars, Jupiter, and Saturn, rather than pinpointing where they're at, I'm just going to say in general they'll be dancing across the eastern sky before sunrise. They're in a nice flat line or a plane, the plane of the ecliptic. I'll show you in just a second. There's going to be a conjunction between the moon and Jupiter and Saturn on the 12th. And there'll be a conjunction of the moon and Mars on the 14th. I won't show you those up front with some static images. I'll try to get to that here in just a second with a moving image. On the 17th, Jupiter and Saturn will be fairly close to each other in the sky. The 24th, there'll be a conjunction of the moon and Mercury. And again, Mercury's only in the evening sky for a few evenings. Hopefully you'll have a good clear sky and be able to try to find this thing on your own. At the 31st of this month will be the highest point in the sky, where you can see Mercury as high as it will be. And actually, I'll probably have a little, not necessarily an animation, but I'll be doing something here with some other software in just a little bit to explain that. So here we are looking at the early morning sky, and you can see from right to left, we're going to see Jupiter, Saturn, and then Mars. This is actually the Mars conjunction with the moon. The moon heads from right to left in this image, and I'll try to actually show you that here in just a little bit with a different piece of software. This is on the 15th, but you'll be seeing this throughout the entire morning. We're looking east-southeast. This particular image is from 5:15 in the morning, give or take. So you're looking just before sunrise. You can see the sun already kind of rising in this image. You probably want to be up around 3:30 or 4 to see these objects rising up above the eastern horizon. So you got to be either a really, really late night owl or a early morning person. Shifting gears to the west, we still have Venus hanging out in the sky, but it's no longer as high as it was. Super, super bright. And these three particular stars, which I'm going to connect with some dotted lines, that is the Winter Triangle. We talked about it last month, how to find it, which constellations they were in. They are Betelgeuse in the constellation Orion. They are Procyon in the constellation Canis Minor, the little dog. And Sirius, the brightest star in the nighttime sky. Seriously, it's really bright. You can't miss it. It's in the big dog Canis Major. These stars will be slowly heading below the horizon, and we won't be seeing them again for a few months. And so if you can, get out there and see the Winter Triangle before the end of the month because these stars are going to be leaving us soon. They will be replaced in the sky by another triangle. We conveniently call those the summer triangle stars. We'll talk about that next month because they'll be nice and high in the eastern sky. Finally, I want to look at this static image. I said Mercury will be rising. Around the 18th or the 19th, you'll start to see Mercury right along the horizon in the west-northwest sky. It's really hard to pinpoint. Venus is a nice bright white orb. Mercury is going to be a lot dimmer, and it's going to be more of a purplish color. And it's only up for a couple minutes to maybe an hour, depending on when you actually get out there to see this thing. But to do that, we're going to need a different piece of software. So let's take a moment to load that and take a look at this. Alright, we are now in our planetarium style software. This is Stellarium. It's a free open source program that you can grab on the internet. I'll leave a link down below. Just wanted to kind of quickly talk about the planets in the early morning before I get on to Mercury, which is the whole point of doing this. But here we are looking east around 3:45, 3:40 in the morning. We're starting on the 8th of May, and I wanted to kind of show you how the moon's going to be traveling through here. So we're going to bring up a date. So there you go, the 8th of May. If we switch to the 9th of May, you'll see the moon will be in the southern sky, and the moon's actually going to be traveling towards the eastern horizon, again going through its phases this entire time. So this is how we get conjunctions of the moon. So this is the 10th, the 11th, the 12th, all at the same time, which is 3:35, 3:40 in the morning. So on the 12th, you'll see the moon will be right below Jupiter, making a nice triangle with Jupiter, Saturn, and the moon. On the 13th, you'll see the moon will pass both of those planets and be between Jupiter, Saturn, and Mars. On the 14th, it'll be close to Mars. On the 15th, it'll have already passed Mars. These are those conjunctions. Again, they look close to each other in the sky, but they are not actually next to each other. Just an optical illusion. Alright, here we go. We're now looking north-northwest. We are here on the 13th of May, looking north-northwest, looking for Mercury, which is currently on the horizon. We're just going to be using this as an example. We're going to advance time slowly. We're starting out at 9 o'clock, give or take. 9:01, I believe, is the actual time at the moment. On the 13th, you don't see Mercury. On the 14th, Mercury will be right along the horizon. We've got it highlighted right down here. All the planet information will pop up, but there, I want you to keep an eye on this little strobing cursor down here. On the 15th, you'll notice Mercury will be a lot higher. There we go. And you'll notice it's going to be getting closer and closer to the planet Venus. This is what I wanted to show. On the 16th, 17th, you'll see Mercury again. It's really close to the horizon. It's not going to be up for very long. You might not even see it till the 20th or the 21st. Just keep an eye on Venus. Look right below it. You'll see Mercury on the 19th and on the 20th. But here's the interesting thing about how Mercury's orbit works. Since it's closer to the sun than our planet Earth, it makes a fun little arc in the sky, and you can actually watch it. So on the 21st, you'll see Mercury and Venus will be nice and close to each other in the nighttime sky. Oops. Let's get that a little bit more. There we go. On the 22nd, 23rd, you'll see the moon appears in the sky. So on the 23rd, right around 9 o'clock, you'll see Mercury, Venus, and the moon right along the western horizon, right after sunset. Probably best to see it right at sunset, so you see the planets first before all the stars begin to appear. On the 24th, you'll see a nice line in the western horizon. You've got Mercury, Venus, Mercury, Mars in that order. You'll also have a little object floating by. It's actually Titan. It's an artificial satellite. Good to know. Thanks a lot, software. On the 25th, you'll see Mercury getting higher and higher while Venus gets lower and lower from our point of view. 26, 27, 28. You'll notice again Mercury getting higher, but all of a sudden, we're going to skip forward a little bit. By June 3rd and June 4th, you'll notice that Mercury is beginning to get lower and lower in the sky. And so, literally, Mercury appears for maybe 3 weeks in the sky. and by the 20th of June, it's along the horizon again. It's too early in the evening, and the sun will still be out, and Mercury will be gone from our point of view. So you have a maybe 2 to 3 week window to get out there and take a look. We're going to rapidly go back in time. Sorry about that. We're not supposed to do that, but if you keep an eye on Mercury, you can actually see this loop again. It's because its orbit is interior to our own sun, our own orbit around the sun, I should say. Just keep an eye on Mercury. Don't worry about where it is in the sky. Just watch as it goes up, and then as June comes around up, it starts to hook back around. That's why Mercury is always kind of really confusing to people, because it sometimes was there and sometimes it wasn't. It just makes this weird little loop in the sky, but not all the planets do that, and it was very confusing. Again, these wanderers, I'm just going back and forth in time to show you its movement from our point of view. If you are interested in that sort of thing, this will actually be in a constellation in May. At the end of May into early June. This is Castor and Pollux, these two stars right above. These are the Gemini twins, and that's where Mercury's going to be as the month goes along. These two twins in the sky. Just kind of wanted to mention that, but yeah, that's the motion of Mercury. And let's get back to our regularly scheduled program. All right, let's get back to our program. Let's talk about the Eta Aquarid meteor shower. So we talked about meteors last month, and again, you can spell it with one I or two. I've seen it both ways, and I don't know what the difference is, but we're just going to go with it. Meteors or shooting stars. In this case, the Eta Aquariids. Before we go any further, let's talk about these things. We did talk about this briefly last month. A meteoroid is actually still in space. It's an object that could be from a grain of dust, the size of a grain of dust, to a small car, to a giant boulder. It's a big space rock floating around, or a small space rock floating around in space. However, as soon as it gets into the Earth's atmosphere, it starts burning up, makes a big fireball. At that point, we start calling it a meteor. Some people like to call it a shooting star. And you can make a wish on it. If you play a certain video game floating around right now, you might make a wish and find a star fragment on your island. Yes, that's an Animal Crossing reference. Shh. Once these things are on the ground, we've got meteorites. That's actually what you will call it. You'll notice on a meteorite, one side of it will be very, very scorched or burned, and the other side won't be. Again, that's if it's coming in at a nice straight angle. It's not tumbling. Meteorites do get recovered now and then, and you actually find them in museums and things like that if you want to see them up close. Here's a couple images of meteors. Again, you can see they have various colors, and it all depends on what they're made of. Some of them are stony, some of them are rocky, some of them are just like straight up iron chunks floating through the sky, burning up. And when they get to the ground, they can be recovered. Here's kind of a good look at one meteorite. And then you'll see this one's an iron meteorite that's been cut open. You can see the lattice work of the stone itself, of the minerals, I should say, on the inside. These tails that I've mentioned a few times, again, they are actually caused by the friction of our atmosphere, but what's interesting about them is that the tail points directly back to where these things come from in the sky from our point of view. Most of the time we're traveling through the tail of a comet that's passed by from long ago. It leaves behind this trail of dust, and when we go through it, we see all these little meteors falling through the sky. The Aquariid meteor shower comes from the constellation Aquarius from our point of view. That point is called a radiant. All these little meteors will be pointing back towards this radiant in the sky. It's usually named for either the constellation itself or the nearest star in that constellation, in this case the Eta star. Not the brightest, not the dimmest, it's just you go A, B, C, D, E, F, G, all the way down through in this constellation. You name it after whichever star is closest. And that's where the name comes from. Nothing too special, but that's how it works. How many will you see is usually what I hear from people. It depends. Some meteor showers are super active. Some of them are not. The Eta Aquariid meteor shower peaks on the 5th of May. It's forecasted to be about 10 meteors per hour. Some places say 15 meteors per hour. That's not exactly a lot. but you can see some meteors if you're lucky. Sometimes you might look up and see it, and if you blink, it's gone. I mean, these things happen really, really fast. If you're more towards the south, more towards the equator, you might actually see more. In fact, if you're a little bit south of the equator, so in the southern hemisphere, you might actually see anywhere between 20 and 40 meteors, just because you have a better view of the constellation Aquarius and the particular part of the sky where this meteor shower will be coming from. Here's a look at it from my point of view here in the northern hemisphere. This is around 3:45 in the morning on the 5th of May. Looking east, and thankfully right now we can actually use, there's not really a lot of bright stars in the sky in this part of the sky, but there are some bright objects, the planets that we talked about just a few moments ago. This will not work next year. This meteor shower happens every year, but these planets are not always there. This year, you can use Mars to help you find it. It's just directly to the left of Mars. So if you can see Mars in the sky, look to the left of it, and you might see a couple of meteors flying towards you, so to speak, from this part of the sky. Just sit back and relax and close your eyes for about 5-10 seconds, open your eyes, stare at this part of the sky, and hopefully you'll be lucky enough to see a meteor traveling from the constellation Aquarius, which we've labeled here. Your viewing pleasure. Let's look back at our menu. What are we missing? Ah, yes, Comet ATLAS. What could have been? What could have been? Shattered dreams, friends. Shattered dreams. Now, if you don't remember what a comet is, it's Frosty the Snowball. So, unlike a meteor, which is, or meteorite, or meteoroid, which are rocky or stony, these are cosmic snowballs, these comets. They do have some rock in them, but for the most part, we consider them mostly frozen. You're going to have frozen gases, frozen liquids. You're going to have some rock, and then, of course, little dust particles. In this case, they orbit the sun. Now, they can be small, 100 meters, 200 meters, all the way up to 20 or 30 kilometers, so that can be pretty big. They do have a tail as well. Their tails are different from meteor tails. A meteor tail is happening because it's burning up in our atmosphere. With a comet, they're actually heating up as they get closer to the sun. And as they heat up, they spew out dust, they spew out some gas, they begin to glow, and that head, that coma, gets really, really big. And you have these multiple tails. You actually have two tails, one of them made out of dust, the other one's actually made out of gas, and they slightly point a little bit differently, depending on the angle to the sun. And we don't really know how many there are, because they come from a really, really far edge of our solar system. There's a place called the Kuiper Belt. It's out there where Pluto and some of the other dwarf planets exist. And there's an even more distant area called the Oort cloud. And this is where the realm of the comets. There's all these frozen objects. Every now and then they'll bang into each other, and one of them will maybe start falling in towards the sun. And that's eventually when it passes Jupiter, it'll start heating up, and that's when we start to notice there's a comet in the sky. As it turns out, I might actually do another piece on this next thing I'm about to say. Some comets may not actually even be from our solar system. There's a comet floating around right now that, doing spectral analysis and actually analyzing the gases, its gas and dust composition does not match any comet from our solar system. So it's unlike the primordial cloud that may have formed our solar system. So where did it come from? It likely didn't come from our solar system at all. It may have come from a nearby star at some point, and over time that star has drifted away from us and we've drifted away from it. But this frozen ball floated through space and eventually ended up trapped in the sun's gravitational pull and started getting closer and closer and closer, and eventually lit up into a comet. And I just think that's really fascinating, so I'll probably make a video on that in a few weeks, hopefully. Here's a good look, sorry for the squeaky chair, here's a good look at a NASA example of a comet. This is actually an animation of what we believe, and actually keep this in your memory, because you're going to see in a little bit there's a picture of an actual comet that looks very, very similar to this. Now, if you're a poor artist like myself, you might draw a comet more like this. The sun, obviously, this is not to scale the sun. The bottom left part, the yellowish sort of egg-shaped object on this screen. The comet's orbit is never going to be circular. It's going to be very, very elliptical, very oblong. Long period comets, they come in once every few thousand or hundreds of thousands of years. They come in, they light up, they either burn up, or they show us their tail, and then they go away, and they don't come back for years and years and years and years and years. You'll notice, again, the ion tail is lined up directly with the axis pointing towards the sun, including a little tip pointing out towards the sun. There's also a dust tail that kind of trails off more towards the orbit of the comet itself. The coma and the nucleus are also labeled. The nucleus, of course, is the core of the comet itself, and the coma is the big cloud around it, almost like an atmosphere, so to speak, around the nucleus of the comet. You'll notice that's really what they look like. This is Hale-Bopp from 1997. Beautiful comet that you could actually see in the nighttime sky, and it stretched across at least half the northern hemisphere's night sky. It was really beautiful. You see the very stark difference in color as well, the bluish color of the gas and the reddish color of the dust. Well, we were hoping that's what Comet Atlas was going to do, become this big Hale-Bopp style object. It was discovered in late December of last year, of 2019. It was supposed to become visible in binoculars. It was visible in telescopes. It was supposed to become visible in binoculars. And last month I said it's going to get brighter and brighter throughout the month, and hopefully through May it'll be visible without a telescope. Well, comets are unpredictable. And this picture came out in mid-April, and people began to notice that something was wrong with Comet Atlas. And you can clearly see it in this picture if you look nice and close up. If you don't see it, there's actually 1, 2, 3, I count 4 different objects in this picture. A better contrast is actually in this image, which definitely shows that the comet itself broke up. And this is not an uncommon occurrence. As they get closer to the sun, they just heat up, and sometimes they can't stay in one piece, and they just shatter into pieces. So my dreams and hopes for seeing a nice bright comet to talk about, well, they're gone. But there is a new hope, and that is actually another comet called Comet SWAN. It is called Comet SWAN, or C/2020 F8. It was actually discovered this year on the 25th of March from the Solar and Heliospheric Observer, or SOHO. The particular camera is called the Solar Wind Anisotrophy. I just messed that up, but I'm not going to edit it out, and that's okay. Anisotropy's camera, SWAN. And right now you can actually see it in binoculars or with a telescope if you're in the southern hemisphere. In fact, the further towards the South Pole you are, the better. It's supposed to be the brightest it can be on May 27th, because that's when it's at its closest approach towards the sun. We're hoping it doesn't break up. This next image actually came from Namibia. It was floating around on a website called Astronomy Picture of the Day, and it is truly gorgeous. I really hope it gets brighter in the nighttime sky. Gerald Riemann is the photographer of this. I do not know him, but again, this image was floating around, and I really thought it needed to be shared. Astronomy Picture of the Day, I'll probably leave a link down below in the comment box if you want to click on it and get this for yourself. This comet, we're really hoping, gets nice and bright, and it should be visible from the southern hemisphere. It'll just be nice to talk about a comet. So let's take a quick review of all of this. Did we get through everything? Final supermoon, the moon phases for the month? Yep, we did that. Visible planets? Yep, we talked about that. The AQUARIID meteor shower? Yeah, we talked about that. And we talked about breaking up Comet Atlas and the new hope of Comet SWAN. Yep, we hit everything for this month's topics. We hope you enjoyed what you've heard. Hope you learned something, most importantly. We really thank you for watching this video. I know you have plenty of other outlets on the internet to find out stuff about astronomy. We are a young astronomy channel on YouTube. We are just kind of building up. We've only got a couple videos. We're hoping to get more and more out as time goes along. Your support is we're so grateful you click. If you share it to someone else, that sort of support is really, really meaningful to us, because we only know so many people. And the only way to get this channel out there is to, of course, get it shared. And shared and shared and shared and shared. So please, if you liked what you have heard, like and subscribe. How does it go? Smash that like button, ring that bell if you want to get updates from our channel. We're going to be trying to do one video a week with the just weekly news, so to speak, of what's going on in astronomy. Once a month we'll be putting up a sky update like this, and as we go along, I'm hoping to start getting a schedule built together so that I can get Astronomy 101 stuff up. Just general information on astronomy so that everybody can learn about this great subject. I mean, anybody can learn this. Anybody can go outside and see the sky, hopefully. If you can't, that's actually also why we're here. If you're homebound or if you're stuck in a hospital somewhere, I want to get you some information, show you some cool pictures, get you some resources so you can learn on your own, or you can teach people. We do have social media if you want to click on those. Like and subscribe there as well. If you're inclined, we've also got a Ko-fi account and a Patreon if you'd like to chip in and help keep the lights on. Not required, but always appreciate it if you do. We do appreciate your time. Have a wonderful morning, evening, afternoon, whatever time zone you're in, wherever you are. May you have clear skies. May you all be safe. Take care. We'll see you next time.